This is netstack.fm, your weekly podcast about networking, Rust, and everything in between. You are listening to episode 18, recorded on December 12, 2025, where Glen has a conversation with Fabien Sanglard about Quake, TCP IP, and Fabien's decades-long journey exploring how early computer systems really worked, from operating systems to hardware and protocols.
Welcome for another week of netstack.fm. This week I'm very excited because my guest of this week is Fabien, or Fab. He is what I call a software historian, even though he also covers hardware. It's not his day job, but I've personally been following him since close to 2 decades on his path to explore and write about how different software and hardware, or even the combination of them, work. So welcome, Fab.
Hello, Glen. Thank you for having me.
Yeah, thank you for making some time. So as is the tradition by now in our wonderful podcast, I think it's nice if you first could introduce yourself a bit, like where you come from and how you came to the job that you're right now at Google.
As far as I can remember, I was always very curious about the world around me. And I always loved, for example, biology, to understand how life works. Civil engineering was also very interesting to me, understanding how electricity was generated, how water was processed, all that stuff that makes things magical, like you switch you flip a switch in a room and then you have light coming in. And of course that applied to computer. What I really like about computers is that it's not just something you can turn on and off, it's also something you can program. So you can put some of your mind in it and then it behaves according to what you decided. And I discovered that at a pretty young age. I think I was 7 when I wrote my first loop, and it was Logo. And in Logo, you have a turtle that you can put down on a sheet of paper and then repeat 360, advance one, put it down, move one, lift it, and then go back to the center and stuff like that. So we had computers at school, and it was a program initiated by a French politician, and the program was Computer for Everybody. So they brought computers, and those were Thomson MO5 8-bit computers, and they were all networked together, and that was really, really cool. Like, we had the optical pen to play with, and from that day I think I was hooked. We had weekly sessions, and I remember distinctly signing up for going after school. So usually I was very eager to leave school and go play soccer, but for computers I would stay after, and I think I easily clocked like 3 hours of programming when I was 7. And after that, it was just a process that was started because I started to ask for computers. So I got a Spectrum, a Sinclair Spectrum at home, and then Amstrad CPC, Atari, and then I moved into PCs. And we almost never had a video console at home. We always had a computer. So I was really used to tinkering, going deep, trying to understand how things were working. And that's how I ended up with a Master of Science in Computer Science. I moved to Canada shortly after I graduated because I wanted to discover the world. And I thought I was going to stay there forever until I got a job offer from my dream company, which was Google. And that's how I moved to USA and eventually became a US citizen. And I'm still employed at Google, and I love it there. I don't see myself ever moving. I work on Android. It's been 11 years. And yeah, that's my introduction.
Very nice. As you work on Android, does it also mean that you are evolved in the Rust adoption, or that you now also have Rust as part of your job? Or I don't know, how segmented these teams are?
I was very eager to jump on Rust. I am the owner of a program called ADB, which is the debugger bridge, Android debugger bridge. And it has a long history. It started in C and it moved to C++. It had many others before I adopted it, essentially. And it kind of suffer from, it's a complex code base with many streams, a lot of things happening. There is multi-threading, there are mutex everywhere. And that's the ideal code base to evolve, to move to Rust. So part of what I do in my job is I'm rewriting some module in Rust, and any new module, we try to write them in Rust. And the latest project we're working on right now is we're trying to improve ADB Wi-Fi to make it more reliable. And Rust is instrumental because you can only run after heap corruption and buffer overflow so many times in your life before you decide that there's a problem with C++ at its core. And if C++ is used right with people who know the language and they love their product and they treat it like almost like their baby and they take care of it and they try to think in terms of architecture when they add a new feature instead of like jamming it in, it can work. C++ can work, yes. But if you want to be 100% sure and that you're never going to have a problem, and if you don't have the ideal condition I just described, Rust is definitely the way to go. And so we've been doing that for a good 6 months now, and I'm so happy with my decision. And hopefully, I'm not going to have to write C++ ever again.
Amazing. I didn't even know you were the owner of ADB. Like, I've used that tools for so many times. I mean, I guess a lot of us, every time you have to touch Android, I mean, it's a wonderful tool. And but I imagine it's probably like quite a big project because it touches like everything.
Yeah, it's hard to make changes because the slightest, most obscure detail or even undocumented behavior is relied upon. We have like millions of developers, and I remember just fixing a bug where we had a command that did not constantly return an error code, and somebody was like, "Oh, I'm just gonna fix that. Put 0 when it succeeds and 1 when it fails." And just fixing that actually broke people because they wrote their test a certain way and they were relying on having unreliable error code returned. So yes, it is a hard project to maintain. It's challenging. That being said, it's used for everything. So you can really make a difference. I remember, for example, improving performance by 20%, and I did the math on how much electricity and times was being saved, power, and even just money. It was huge when you add up. So the slightest thing matters in both ways. You can create a lot of problem for people if you're not used to that kind of product, but you can also greatly improve the quality of life. And that's why what I like the most, and that's what we've been doing with ADB Wi-Fi.
And talking about ADB and the Wi-Fi, how does the network stack look like? Is it just piggybacking on the one of Android, or does it bring its own tools and own protocol implementations?
No, so the guy, the person who wrote it originally, Sweatland, really did not like to have dependencies, and he really liked to write everything. So no, it's just using TCP and USB. There are no dependencies, and it's doing all of the multiplexing manually. So nowadays, if you work with USB, you have something called stream to multiplex, a little bit like the way TCP does, but you cannot do that on USB. You could not do that back in the day with USB. So that is done manually with something called the A protocol. I'm not going to jump into too much details, but that's everything is done pretty much in-house on ADB.
Yeah, I mean, then again, you said was it originally in C++ or what was the
No,
original
originally
language?
it was written in C.
Okay.
And then the code base was evolved to C++, and now it's evolving to Rust.
Because I mentioned because both in C and C++, and that's also what I'm used to. It's not that abnormal to just write everything yourself, right?
It's pretty rare, but I think on ADB we've been beat quite often by using a dependency or something, and then the level of support changes, or we need to make changes that are not compatible with the way the people want to see the code base go, and then you're stuck, and you have to fork the project, and you're in a worse place than you would have been if you had just written your own stuff, because now you have like all that framework that does a lot of things that you don't need, plus your stuff. So that's why things are done this way.
Okay. And then so, like I said, I've been following your blog since quite a while. At times you were very active, at times not, but anyway, I'm subscribed to, so I can see them coming in.
There was there's a 3-year gap. Yes, in my updates, it's when I was trying to write my first book, and I gave up 2 or 3 times. I forgot how many times I gave up, but yeah, all of my time was spent trying to make the book happen.
Okay, that's a valid excuse, and not that you need any excuses. Like it's anyway, it should be fun, right? It's a blog, so not something. It's not a second job, I would think. So
as I often say, it's not excuse. There are no excuses, but it's a reason. It's an explanation.
Very good one. I'm getting a lot of knowledge already from you. So how do you pick these topics? Do they just like, I don't know, for example, recently you wrote like a lot of, not recently, but like this year, I saw a lot of blog articles from you about the IBM machine. Like, is it because you bought one or?
No, it was the other way around. So the way I go is that I just follow my curiosity. I mentioned earlier that I was always very curious, which is good in a way, but it also can be a curse if you don't keep yourself focused. So usually when I pick something and I start to be interested in something, that's why I write this article, because that's a way for me to have a closure. And if I don't write something about it, I don't allow myself to move on to the next topic. It doesn't always work, but it mostly does. And that's the way I found that I'm able to move forward and make things work. Otherwise, I just disperse myself. And the way it works, for the case of the IBM, it was just a childhood memory of my first PC being severely underpowered. I was playing Doom at 10 frames per second, and the neighbor had this beautiful IBM, which was running Doom flawlessly at least 20 frames per second, which back then was a very high number. And I was like, I've always wanted this machine, and I always wanted to explore what it could do. And I just went on eBay, and I started to find if they were available. I started to do some research, and I eventually got one, and it's a box I wanted to check. But on a more general term, I think I'm always driven by curiosity, which is itself finds its root in passion. I think if you're passionate about something, you're more likely to eventually to keep working on it and kind of complete your small project. And that's how things happen with me: curiosity and passion. If I force myself to work on something, it can be good, but usually I find that it's not as good as it could have been.
Okay, and the fact that you make a blog post around it, is it always like on purpose, or is it more like in general you are curious, you are discovering things, and at some point you have sufficient notes, or you think like, okay, there is more here, and only at that point you start to maybe think about an article?
So the article is usually for me a way to complete a topic I was working on, and it's a way for me to verify that I've actually done what I intended to do. I found that very often when you try to explain something to someone, if you don't really master it, the cracks are going to be very visible. So writing something at the end of a project is for me a way to check that my knowledge is sound and I've actually investigated everything I wanted to look into. And quite often, while I start writing an article, I'm like, oh, I have this idea and that's actually very interesting. So I go back to the project and I work some more on it. So it's it's a way for me to check that I understand and I master my topic. It's also a way for me to kind of not waste my time, because I'm like, a lot of people investigate super interesting things and they never write about it. And I've met people like that very often. People super knowledgeable. You go on a forum and they know everything about a video game or about a game console, and then they don't write about it. This knowledge is there, but it's not available. So I always kind of think of somebody who may be interested in this topic. I quite often mention that I write the book that I wish I could have just have bought, like the Game Engine Black book about Doom and Wolfenstein. I'm quite lazy. I just wish I could have bought this thing because I was interested in it. And there are many books that I write and people have done exactly what I do. They were very interested in the topic, they wrote about it, and I just can spend the money and they save me all that time by sharing their knowledge. So it's kind of a way for me to return the favor in a way.
Yeah, very cool. And so, like, for example, a blog post I liked from you a couple of years ago was the one about mDNS, where you kind of like wrote like a little mDNS primer, and you linked to a YouTube talk there, I think, about Bonjour, if I remember correctly. And I think you even mentioned, I mean, what I found most surprising is also that the fact that you at that point mentioned the Unix network programming, which is quite a piece of work, like to get through it and to read it. If you look back at a blog post like that, like, do you still like that kind of like article, or how do you feel about such articles after some years?
That's a very interesting question. The further back in time I go back and read the stuff I wrote, the more I cringe. Which in a way is a good thing, because it means that my English and my skills in a way is improving. But the very early articles, I'm kind of embarrassed of them. I keep them online just because I think somebody may find them interesting. But the English is like, it's riddled with errors. It's not very deep. Like the typesetting is embarrassing. So some of those, yeah, I have it's a bittersweet feeling to read them. All the ones I wrote, I think, after I wrote the books, I think I really started to really put a lot of effort into presentation, and also my English improved quite a lot over the years. So the one you mentioned about mDNS, I'm very proud of them. All the ones I wrote after I changed the layout, with the monospace font, they are pretty solid. And I kind of plan on writing more about mDNS, by the way. mDNS is a core technology used in ADB Wi-Fi, and that's why I wrote about it. And so more of those will come if you enjoy mDNS. But yeah,
I mean, yeah, I enjoy anything about networking basically. So it's I can consume these, and I mean, I like it especially because to me even though I originally come from the game industry, ever since I discovered like network protocols and how they're implemented, I feel they combine so many things together. They combine low level protocol implementations. They combine even like the fact that there is a reality, there is a world there, so you have to deal with that, which causes latency in all kind of ways. There is the fact that you connect different machines together that now need to correspond with each other. There is like the matter of security, like it's yeah, I mean, like it's to me it's like a little bag of candies because it combines everything basically.
So I would say that you are the ideal reader for that kind of article. But when I write, I always kind of give myself the challenge of how can I say that? You've probably had, everybody has had a teacher at school where like, I did not like this topic, but that guy was so good, I loved it. And I have vivid memories of a teacher who was teaching history. And before that, I was never super into history, but that person always came up with anecdotes and a way to present things that was interactive, and I became passionate about history thanks to this guy. So when I write article, I kind of always give myself this challenge to like try to make it interesting. And if I can make people who are not like you, who are not interested in networks, and if I can make them like mDNS or be interested in mDNS, that's really when I think it's a big win. And it's challenging with network protocol because they are not very well documented. Usually, you have like RFC somewhere, and if you're lucky, somebody wrote a book about it, like in the case of mDNS. But there are many topics around which I would like to work on and just not dumb them down, but just make them more attractive to people and be like, it can be fun to read about them.
Yeah, that's a very good challenge. And anyway, it will make search articles better for everybody, I imagine. Now, you also wrote a bit around the SNES. Like, it's also a very interesting topic. Not so much we're going to discuss today, but what I do, kind of, I'm not sure if I missed that, but I found it very interesting how back in those days, the cartridges, I mean, they weren't just storage devices. They weren't just storing your game, your assets. They were also often bringing their own hardware, like to bring capabilities that the machine, be it like a console or a handheld device, didn't have. And I found that quite magical because as a child, let's say you have some kind of Game Boy or you have some kind of console, and suddenly it can do a lot more. And it's basically because they bring their own hardware in those cartridges.
Yes, it did feel magical as a child to play the Super Nintendo. And what's remarkable is that even when you lift the hood and you start to learn how it works, to me it becomes even more magical because I understand the constraint they were under, and they still managed to make some of the best game of all time. And it was really vivid to me when I started to study the video system. I'm not going to go into too much detail, but like you have 7 modes for the Super NES for the video, for the graphic rendering, and every single one of them is pretty much pushing the hardware to its limit. Everything was based on RAM latency, because you need to output a color for every line, for every single pixel. So they could, like the CRT never waited. You could not just write a frame buffer and then transfer it when you were done. You were just issuing pixel as they were needed. And to me, that's what even more mind-blowing. And that's also an inspiration for what I work on every day. It's always the same story. It's always been the same story of people inventing things. You are you have limited capacity in terms of like processing speed or storage. And it used to be true when you were programming a web server back in the 90s, or even nowadays when you work on an LLM. We routinely mention billions of parameters, but they are limited and they need to do the best they can with what they have. And that's what I get a lot from looking at those old machines, is that the mindset is still the same. You push as hard as you can with what you have in order to reach a goal.
Yeah, that's for sure. And I hope we keep pushing, although not forget to be kind to each other. But yeah, that said, like, I enjoyed it a lot, and the reason why I wanted to invite you mostly is also around your Quake article, where you mentioned, like, okay, a bit of the history, like how did it get like its TCP IP stack, and it's mainly, I think, around the like more modern version, not the super modern version, but like on Windows 95 and beyond. But you do start the article talking a bit about like how it was like on DOS. And as far as I remember, in a system like DOS and the ones before, like systems had to bring kind of like their own network stack. But I wonder, like, did developers write it each time from scratch? Like, did every company have their own implementation, or were there some like library vendors and you could kind of like license their code from that?
So in the early days, you could buy a network card and you could set up a network on top of something called IPX. And for IPX network, you did have stacks that came with the network card. So you had a driver for that. So it worked. It worked really well, but you were limited to a local area network. As soon as you wanted to go on the internet, you need to have a TCP IP stack, which is way more complex. And back in the day, you had to buy one, which was almost $1,000. It was extremely expensive. So from what I read of the little open source, the little source code we have about games of those era, usually people were just going with IPX. It's only, as far as I know, with Quake that they made this like really convoluted bridge to be able to access WinSock under Windows 95 that people really were able to play on internet. But even then, it wasn't perfect. I mean, the things that really is really telling by how early they were is that John Carmack had to write Quake World because he found out that as soon as you had more than 300 milliseconds of ping, his architecture would not work anymore. He had to introduce prediction on client side. He had to allow the player to move before it was acknowledged by the server. So I think developer never wrote TCP stack. It's just too complicated, to answer your question. And with Quake, they used the one from Windows 95.
Okay, yeah, that makes sense because I mean, I don't remember any multiplayer game that I played, like multiplayer as in internet game on those systems. Like the first internet connected games I played was already on something like Windows 95. So that makes sense. I mean, I guess they must have existed, but yeah.
So what you did have, for example, with Doom is that you had companies who will specialize in forwarding connections. So Duango, for example, did that. You could run the program, it was a TSR, that would forward the Doom packet to their server, and then they would let you play with people which were not on your LAN. It was kind of internet before time. But the architecture of Doom was very different from the network architecture of Quake. When you play in a network in Doom, for example, every single machine, they are running their own simulation, and they can only render the next frame once they have received the command for every players. So even if you had a Pentium able to run at 35 frames per second, if you were playing with somebody who had a 386 and was running at 10 frames per second, your frame rate would drop down to 10, because your machine could only render a frame once it had received the command from all the machine, including the very slow 386. Quake moved to a very different architecture where you had a central server and all the clients were being updated asynchronously. So that worked better. And that was the first version they had, where they had a dumb client which would just send commands and only do something when the server had acknowledged those commands. And that worked well for the testing, because I think John Carmack was on a T1 line with very low latency. But as soon as they put it in the OpenNet, that system didn't work very well, especially when you were moving around. So you could look around, and that did not require the server to acknowledge anything. but as soon as you wanted to move, that had to be acknowledged. And as soon as you go past 300 milliseconds, it starts to show, and it's very noticeable. So they solved that with Quake World, where they were predicting and allowing local command to be acknowledged temporarily until they were validated by the server later on.
Okay, very cool. And then, as you mentioned yourself, like for Quake on Windows 95, they did build a bridge. We can talk a bit about what that bridge does, but I wonder why they needed a bridge altogether, because I thought that starting from those kind of operating systems, the OS was first of all already in control. Even if you start an application, it was still running on top of the OS. And on top of it, I thought it came already with like a pretty complete network stack, no?
Yes, so Windows 95 had a TCP IP stack, but when you started those applications in Windows, it put it in a virtual machine. So it's called a DOS box. It's not related to DOS box, the software that was written later on. And the memory access, the interruption, and the signal and the interrupt are all virtualized. It has a pretty significant impact. So I think it's almost 25% slower when it's run in the DOS box. And the other thing is that, yes, there is a TCP IP stack. There is a DLL that gives you functions to send packet on the internet, but you cannot load a DLL from DOS. DOS has no concept of DLL. And that's why they were using this bridge. So its software did not write this bridge. It was a software solution provided by Empath. And it was quite complicated what it did, because I'm not going to go too much into details, but they had to create like a virtual device that will be tied to an interrupt. And when Quake running in the DOS virtual machine will trigger this interrupt, it will be recognized and intercepted by the virtual device, and it will be able to access WinSock. So yeah, just to shorten my answer, DOS provided no network protocol. There's nothing in DOS. DOS is a glorified file system with a command line and able to execute bash script.
Yeah, I mean, I have fond memories from it, but yeah, it was definitely different than what we nowadays call an operating system.
Are those memory really found? I mean, I don't know. I spent so many hours trying to get enough conventional memory, and having to figure out if I needed EMS RAM or XMS memory, or even loading a mouse. Back in the day, you had to actually load a mouse driver in your AutoExec.bat. So it worked.
Yeah,
But
I mean, I get
remember,
you.
we did all that without internet. No internet. How do you figure out if you have a problem? There was no LLM to ask guidance. Maybe you had a friend somewhere in town you could brainstorm with. But I actually remember back in the days coming across a file with an extension I did not recognize. It was .rar, a RAR, and I was like, "What is that? What do I use it?" And then I asked a friend. He's like, "I think it's a compression. It's a compressed archive." And he had this thing called unrare. But that illustrates how difficult it was to get access to information and software. Like I often mention difficult access to information, but if you wanted to program a computer, you need a compiler. And a compiler was easily $2,000 back in the days if you wanted to work in C or even Pascal. So it was a very different era. So I don't know, when, I think people tend to put like rose-tinted glasses when they look back. I'm not sure those are fond memories.
Yeah, I mean, I'm sure you're right. I'm sure the truth is somewhere in the middle. Like, and I do remember indeed, back then we were still buying compilers because I received from my uncle a license for like the Borderlands compiler, and I was so happy. Now I could compile some, what was it, like, I think C code, and yeah, I don't know. But at the same time, I felt it was like all more manageable because nowadays systems are so complex, and I mean, we do have a lot of experience, and we always find our way, but at the same time, you can never feel like you always feel a bit lost. I don't know, like it's for everything. Like the commands have 1,000 flags by now, and there are like 1,000,000 protocols, and I don't know, like for example, back in the days, those let's say a CPU, you could still kind of like comprehend what all the instructions were, and now they are like, I don't know, like you need like a set of books just to get to list all the instructions, let alone like understand them. So it's yeah, it's a lot more complex, I would say.
I think it's a lot more complex. You also have a lot more documentation. I don't know if if it's a net gain or not, because back in the days things were simpler, but we have little documentation. Like if you wanted to implement a TCP/IP stack, even if you had the compiler, you need to get access to the specs. I'm pretty sure you had to pay for the specification. It was like expensive. So I don't know which side is better. I think perhaps it's always the same story. You know, you have a certain amount of resources and you're trying to make something happen, and it's always the difficulty level is the same. What is not the same though, and I would agree with you, is that things did feel magical. If you were playing a point and click or Monkey Island, for example, you didn't have access to an internet page telling you the solution. I really felt back in the days that I was adventuring and discovering things, trying to make things work. It was you and the machine, and maybe some obscure TXT file buried somewhere that you had to discover yourself by looking into the directory and the hierarchy. And I do have fond memory, now that we were bringing it up, of solving problems on my own, and that was very valuable. Nowadays, I would say, quite often, if you have a problem, the first reflex is going to be to Google it. And yes, you solve the problem faster, but you feel a little bit less accomplished.
Yeah, exactly. And yeah, I mean, yeah, anyway, I feel like I'm gonna go on a complete side road, so I think I want to stop it early.
Maybe we can do another podcast about it.
Yeah,
it was better before. I'm like, no, it's better now.
Yeah, that seems like a different kind of podcast to all the guys shouting at the sky. That, why not? Give us some years that we can do that. Okay, so that's very cool. But then I guess later Quake versions, then they no longer need those books because they will be made for the new system, and then everything is a lot simpler, at least networking wise, I guess, for them.
Yeah, so in 97, id Software converted their development stack to Windows NT. And they started to, they stopped developing for DOS essentially because DOS was just losing a lot of ground very fast. Within 1 year, I think DOS lost 50% of the market share. And it was really all Windows 95, Windows NT, and later Windows 2000. So everything they wrote after Quake, I think, was all based on Win32. Quake.exe and vQuake were the last DOS compatible they ever released. And after that, it was all Windows, and on Windows you had everything you needed. And what's really cool is that I think the code base became better and better. With Quake, when you look at the source code, you can see all the things they try to experiment on. For example, they forked WinQuake into a Quake world. So when they release the source code, you have actually two source code. You have two huge folders. One is WinQuake, the other is Quake world. Whereas if you look at Quake 2 and Quake 3, it's just one clean, unified code base. And it keeps on improving. For example, if you look at the source code of Doom 3, they have a unified renderer where the models and the world are lit exactly the same. They are affected by the same shadows and stuff like that. So it's really fun to take a trip in id Software code base because get better every year with every new version.
Can you imagine? And then, despite the fact that you wrote a lot of interesting books, like you wrote one, I think around Wolfenstein 3D, around Doom, and I think one related to arcade machines, if I remember correctly.
Yes, the Capcom CPS one, the machine running Street Fighter 2 and Final Fight, and all those early, I would say, milestones from Capcom.
Yeah, exactly. But like despite the fact that you write also quite often about networking, so far you didn't really have any book which dove maybe a bit in the topic around networking.
I think I'm very tempted to write about mDNS. I love mDNS. It's a really cool tech, and there's only one book about it, and it's from a long time ago, so maybe I will write about that.
Yeah, very cool. And you also have, I mean, I'm not sure, we also had some episodes on our podcast around fuchsia, and I guess you have a lot of people there that can probably teach you a bit or two about networking as well.
True. However, when it comes to network, I think you really need a lot of hand-on experience. You cannot just read the source code of something and really understanding it well. Networking is really a little bit of black magic sometimes, and also the source code I've read is usually not super well documented.
Yeah, that's true. And it's kind of like mathematics, I guess, where, I mean, you can read as many proofs as you want. If you don't do them yourself and try to figure out solutions, then you kind of just kidding yourself that you know it.
Something that really helps to understand network code is to have good example too. Like if you can have a UML diagram or a sequence of packets, it helps a lot. And I really rarely find those in networking code base.
Okay, so maybe that's a good one because I myself, I also develop and maintain a network framework called Rama. And so far we've been developing it for 3 years, and I hope it can go for many decades onwards. And the first years were mostly around many iterations trying to find the appropriate design, because then the rest can be built on that. And yeah, the year that's coming, one of my resolution is to rewrite the documentation and also maybe make some kind of let's say tutorial kind of space where they can also, there's already plenty of examples and tutorials, and I try to explain things around what are different kind of proxy concepts and this and that. But as you already mentioned one thing where you say okay, a good diagram is good. So maybe you can give some tips around this then, and this way I can apply it and try to provide better documentation for people to, because the goal of it is to really empower you, not just with the technology, but also demystify a bit about networking and hopefully that they also learn to enjoy and the amazing things they can do with networking.
So yes, my advice, I think everybody's brain works differently. So it's really hard to appeal to everybody. What I found though is that I've never heard anybody telling me they hate drawings. So I think it will be pretty safe if you were to put a lot of them in whatever you write. Like for example, in mine, all of the books I wrote, I think I have hundreds of drawings in them because I think it works super well with me. Even when one of the articles I wrote, which is the one I get the most feedback about, is when I explain how floating point works. And pretty much every emails I receive mention the drawing. Instead of explaining it with a mantissa and the exponent and stuff like that, I explain it with a window and an offset. And that's something that keeps on coming back. And I think I could almost have published an article with 50% less text and just have kept those drawings. That would have been enough. It's actually a really interesting exercise to try to see how much you could shorten an article and still have the core of it. I think I forgot to say that something is finished when there is nothing, not when there is nothing to add, but when there is nothing to remove. And it's a very interesting approach.
Yeah. And yeah, do you have any tips around like how you would like draw those diagrams? Because I find that sometimes it's maybe too simplistic, and at other times maybe there is just too much on it.
So my advice about that is to let it rest. So the way I proceed is that I write something and I draw something and I stop looking at it for a few days. Because if you're too close to the sheet, you don't, I don't know, somehow you lose the big picture and you start to draw into details, and you lose something when you're too much into it. So, and that's something I've done for everything I've written so far. Write it, don't publish it, leave it a few days, come back to it with a fresh mind. You will have forgotten your approach, and you're going to be able to rediscover what you wrote, and almost like one of your readers. And you will quite often you spot mistakes there. You're like, okay, it's not clear. I don't understand what I meant there. And I think it depends how good or bad your memory is, but I think a few days is enough for me. It may be longer for people, but yeah, give yourself time.
Okay, very cool. And did you ever try to make some kind of like interactive diagrams where they can see, like, let's say, for example, if it's networking, that they actually can see the networking go in its flow, or did you so far stick to like static diagrams?
I have a preference for static. I did do interesting interactive things. So the Doom 3 article, for example, you can click and you see a scene being rendered as every light is being blent in the frame buffer. And it's cool. And in this case, it's one of the few instances where it was working and it was better than having it static. The question you have to ask yourself when you make it interactive is that, does it help people understand my stuff, or does it make it cooler and more complicated? I mean, the answer is obvious, but it's hard to draw the line.
Yeah, that's true. And so throughout your time at, if we come back a bit to what you were discussing earlier, that the fact that you are now the owner of ADB, and despite that, the fact that there is some things that like bite you because of the fact that there's so much written by itself, at the same time, there might be some unique qualities there. So I wonder if there is something there in its network stack that you've never seen before and that you think is pretty outstanding and that you would like to see more done, or a pattern which helps in the network logic or whatever.
It's hard to answer because it serves such a, it has such a narrow purpose. Very important, but it's about ADB communication. So how to generalize that with a pattern? I don't know. One thing which is really good is that I think they got a lot of good things right. Having a server was a good thing because some resources have exclusive access. So, for example, accessing a USB interface, a USB interface cannot be shared by multiple processes. So you needed to have a central server that was long-lived and with command accessing it. So the architecture is sound. The way they multiplexed streams on top of a protocol, so they built a protocol on top of that could work on top of TCP or USB. That was also really cool. In terms of generalizing things, I cannot really come up with anything. But I know that the way they worked was iterative. So, for example, they would write something and it would serve its purpose for a few months and then they would rewrite it. And that was very impressive. And that's how a lot of really skilled developers, such as John Carmack, worked. They would just have a prototype, learn from it, and rewrite it until it reached the point where it was solid. And I think that's what they did with ADB. So the thing I would recommend to people is not really a template or a design pattern, but a way to work, which has worked well. But it requires two things. First, it requires you to be really kind of fast. If you do too many errors, like off by one, and you lose yourself in like memory corruption, it's not going to be practical. You cannot do that. I think John Carmack was pretty modest when he mentioned that he wrote something. He made it sound like he wrote Doom with just basic high school trigonometry. But one of the things he had for himself, I think, is that he didn't make too many mistakes. He was able to move very fast and iterate. And that's what they did with ADB. They had a very a star coder, Sweatland, and he proceeded this way. And I was told that the way he worked was actually very impressive. He will start at the top of the file and write everything, all the functions from top to bottom, and then compile, and it will work. And that kind of thing just blew my mind. So yeah, not a template, but more of a methodology.
Yeah, I mean, I'm sure he iterated a lot in his head as well. But yeah, it's that's a true craftsman at work. Yeah. So that's I like to see that kind of stuff for sure. And I take away the advice, and it's also what I sometimes tell people is like each time you rewrite something, you basically also master the topic a bit better, and so the next version is going to be better. So it's not a matter of overthinking too much about the first design, but more like apply your knowledge, apply the skills you have so far, and the mastery you have over the topic, implement it. It will serve its purpose, but then after a while, you will have learned more about the topic, and you have also have some more, like now maybe production experience with this module, with this library, with this binary, and maybe apply that knowledge and rewrite it, or the part that needs to be improved or is beyond its design limits by now.
Yeah. So, and in terms of iteration speed, when I mentioned that people just were able to write something top to bottom and then it would just work, I think it's something that's doable in C. I'm not sure it's possible to do it in Rust, or maybe I'm not. I've read many reports of people online who have been working with Rust many years, and they're like, I still get caught by the borrow checker, like my design doesn't work and stuff like that. So you've been working in Rust for 10 years. Do you think you have it's possible to reach a level of proficiency where you write something from top to bottom and it's like the borrow checker never catch you?
I don't think so, but it's also, I think it's also on purpose, because you kind of learn to rely on it, right? Like it's kind of like your second conscious. And in let's say in C, you wouldn't really do that. Like, I mean, I never saw the compiler as an ally to me, because like pretty much anything could pass in the C compiler, and it's very subtle sometimes. Like sometimes, I mean, like I said, I really was programming mostly just in C, C++, in the first half of my career, and like sometimes let's say you just have some kind of maybe you replace a const with something, or like your pointer is now not a const pointer, or I don't know, there are very subtle details and you can easily overlook them, and you wouldn't even be able to check your compiler output either, because like maybe I was just working in bad code bases, but I remember they were always full of warnings, and you had to kind of like learn from the senior people, like, yeah, those are all the warnings you need to ignore, and those you pay attention to. But it's very easy to then like forget some important warnings, even though maybe they should be errors if they can make your program not work or something like that. But I think in Rust you kind of like rely on it, and of course there are also things where, like as a human, you can probably be pretty certain, or at least you think you're pretty certain that should be able to be allowed, but because the borrow checker cannot verify it, it doesn't allow it, and then yeah, I don't know, like.
So you think it's not possible?
It depends if it's simple enough. Not. It depends what kind of file it is. I'm not sure what kind of file we're discussing here, but because I think if the kind of code that most people write, which isn't like, I don't know, like a low level voodoo magic where you also need to go into, try to work around your borrow checker. I mean, that's where that kind of things happens. Like most people write business logic, and I think in those, I think it is possible. I don't think you have to worry about it. Like in that kind of code, like the only times when I'm still being caught by the borrow checker is when I'm trying to be clever or need to try to do something very optimized, and I need to kind of like step outside the bounds of what the borrow checker can do. And then there are other kind of tools like Miri and all kind of other things which can help you there. But if you write the typical kind of code with your business logic, I do think it's possible, yes. Then you wouldn't, I don't think I'm ever surprised till there. So there is hope for you.
There is a hope. I like that.
I mean,
that's what ties it last in the man, hope.
Yeah, I mean, that's what I'm often confused about, because, okay, like often, I don't know, like whatever is the messaging around Rust and this evangelism, I don't really buy. For me, just a tool. And I never see people being enthusiastic about screwdrivers. So I wonder why people are so enthusiastic about programming languages. For me, it's a tool. But what I do think is, I mean, if there my program compiles and I have also a sufficient amount of like unit testing actually like kind of like business logic, like maybe things which as much as possible you try to codify it in your type system, but sometimes you cannot. And then like, I mean, in the end, there will be some business logic that is just, you need to verify in tests, be it unit tests or integration tests. But so I make sure I have those kind of sets, and the combination of the tooling that comes with Rust, like just its compiler, its capabilities, and then the filling the gaps with some tests. Yeah, whenever I then at that point I can just refactor code base and it does just work. That is maybe different from your question where you say like maybe the compiler will complain and have to iterate a couple of times with the compiler, but in a way for me that's a superpower, not an annoyance, because if I would do that kind of refactor, let's say in C or even in a memory safe language like Go or Python, then I would be very paranoid and I would be very scared, and I would definitely not try to just ship it, because I would totally not trust if I didn't make some kind of mistake, as edge cases might be.
I see. Okay.
But I think you can be very proficient in it and very fast in it. Like but it's a matter of time, I guess. But if you come from C or C++, I would think that you will have a good time. I would think, and it seems that you have a good time. So I think we talked about a lot already, and at the end of the episode, I always want to let my guest give some opportunity to, maybe if you want to plug in something, or maybe we talked about something or we didn't talk about something and you do want to talk about it now, or you want to expand on something we talked before. So now is definitely an opportunity for that.
No, I don't do a lot of self-promotion. For example, on my website, one of the things on my website is that there are no analytics. I don't measure the traffic. I just put things out there and hope people can find it interesting, maybe. So I would just say keep being curious. As you mentioned, keep being kind to each other. We need it a lot in these times. And that's it. That's all I have to say.
Okay. We thank you for your time, Fabien. Like, I hope you will keep finding the energy to write these deep dives. Maybe I think we got confirmation from you that you're gonna write an mDNS book. So I'm already gonna pre-order that one. And I wish you all the best in the rest of your life.
Thank you very much. Thank you for having me.
netstack.fm is brought to you by Plavayo, building secure, open, and resilient infrastructure with Rust, protocols, and purpose. This show is also made possible by Rama, the open-source networking framework. Plavayo offers service contracts and welcome sponsorships to keep building and supporting its ecosystem. The theme music of this podcast was composed by DJ Mailbox. If you enjoyed this episode, don't forget to subscribe on your favorite podcast platform and leave a 5-star review. It really helps others discover the show. Thanks for tuning in. We'll see you next time for the next handshake.